Hi students, we will discuss inverse trigonometric functions in this video. We will discuss synopsis first and then we will discuss few questions which appeared in previous year Karnataka CET. First we will see what is an inverse trigonometric function. We know that f from a to b is a function if f from a to b is a function, f inverse from b to a is defined only when f is 1 1 and on 2. That is, if a function is bijective, then the inverse of that function exists. So to define inverse trigonometric function, we have to restrict the domain and codomain of trigonometric functions. As a consequence, we have the following table. So you can refer this table. Y is equal to sine inverse x. This inverse trigonometric function is defined when domain is closed interval -1 to 1. That is, if the x lies between -1 to +1, then y equals sine inverse x is defined. And its codomain is closed interval -pi/2 to +pi/2. That is, y lies between -pi/2 to +pi/2. Similarly, for y equals cos inverse x, domain is closed interval -1 to +1 and codomain is closed interval 0 to pi. Y is equal to tan inverse x. For y equals tan inverse x, domain is whole set R, set of reals, and codomain is closed interval -pi/2 to +pi/2. For y equals cot inverse x, domain is R and codomain is open interval 0 to pi, that is 0 and pi are not included in the codomain. For y equals secant inverse x, y equals secant inverse x, we have domain R equal R minus open interval -1 to 1, that is -1, this interval -1 and 1, open interval -1 and 1 is excluded in set of real numbers. That is the domain of y equals secant inverse x, and codomain is closed interval 0 to pi except this pi/2. For y equals cosecant inverse x, domain is same as y equals secant inverse x, and codomain is closed interval -pi/2 to +pi/2 excluding 0. So this table indicates the domain and codomain of all 6 inverse trigonometric functions. Now we have this definition. Sine inverse of sine y will be y for all y belong to closed interval -pi/2 to +pi/2. Cos inverse of cos y equals y for all y belong to 0 to pi, that is closed interval 0 to pi. Tan inverse of tan y equals y for all y belong to closed interval -pi/2 to +pi/2. Cot inverse of cot y is equal to y for all y belong to open interval 0 to pi. And secant inverse of secant y is equal to y for all y belong to closed interval 0 to pi except pi/2. Similarly, cosecant inverse of cosecant y is equal to y for all y belong to closed interval -pi/2 to +pi/2 except 0. And sine of sine inverse x, next so we can take this as a property. Sine of sine inverse x equals x for all x belong to the domain of the definition, that is domain of sine inverse x, x belong to -1 to 1. And cos of cos inverse equals x for all x belong to closed interval -1 to +1, and tan of tan inverse x is equal to x for all x belong to R, and cot of cot inverse x is equal to x for all x belong to R. Cosecant inverse of cosecant y is equal to y for all y belong to closed interval -pi/2 to +pi/2 except 0, and This we discussed, and now secant of secant inverse x is equal to x for all x belong to r minus open interval minus 1 to plus 1. Cosecant of cosecant inverse x is x for all x belong to r minus of open interval minus 1 to 1. And we have this property, sin inverse of minus x is minus sin inverse x, and cos inverse of minus x is pi minus cos inverse x for all x belong to open interval minus 1 to 1, and tan inverse of minus x is minus tan inverse x. So in this slide you can observe, for cos inverse of minus x it is pi minus cos inverse x, whereas sin inverse of minus x is minus sin inverse x, and tan inverse of minus x is minus tan inverse x for all x belong to R. Similarly, cot inverse of minus x is pi minus cot inverse x, and secant inverse of minus x is pi minus secant inverse x. Of course, we have to consider this x belong to R in this first case, and in case of secant inverse of minus x is pi minus secant inverse x for all x belong to R minus open interval minus 1 to 1. That means set of reals except this open interval minus 1 to 1. Cosecant inverse of minus x is minus cosecant inverse x for all x belong to R minus open interval minus 1 to 1. Sin inverse of x is equal to cosecant inverse 1 by x. This is another property. Sin inverse of x is nothing but cosecant inverse of 1 by x for all x belong to minus 1 to 1, that is closed interval minus 1 to 1 except 0. Cos inverse x is secant inverse of 1 by x for all x belong to minus 1 to 1 except 0, that is closed interval minus 1 to 1 except 0. Tan inverse x is cot inverse of 1 by x if x is greater than 0. For x less than 0, tan inverse x is minus pi plus cot inverse of 1 by x, and cot inverse x is tan inverse of 1 by x if x is greater than 0, and pi plus tan inverse of 1 by x if x is less than 0. And secant inverse x is cos inverse of 1 by x for all x belong to R minus open interval minus 1 to plus 1, and cosecant inverse x is sin inverse of 1 by x for all x belong to R minus open interval minus 1 to 1. Similarly, we have another property, important property, sin inverse x plus cos inverse x is equal to pi by 2 for all x belong to the domain of the definition of sin inverse x and cos inverse x. Next, tan inverse x plus cot inverse x is equal to pi by 2, and we have one more property, secant inverse x plus cosecant inverse x is also equal to pi by 2. Here, if x greater than 0 and y greater than 0 and xy is less than or equal to 1, with this condition, tan inverse of x plus tan inverse of y will be equal to tan inverse of x plus y by 1 minus xy. If x is greater than 0, y is greater than 0, and xy is greater than or equal to 1. So you can note the difference here. In the first case, it is xy less than or equal to 1. Then it is tan inverse of x plus y by 1 minus xy. When xy is greater than or equal to 1, then tan inverse of x plus tan inverse of y will be pi plus tan inverse of x plus y by 1 minus xy. So tan inverse of x minus tan inverse of y will be tan inverse of x minus y by 1 plus xy for all x greater than 0, y greater than 0. So these are a few elementary formulas. 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square for all x greater than 0 and x square is less than or equal to 1. 2 tan inverse x is equal to pi plus tan inverse of 2x by 1 minus x square for all x greater than 0 and x square is greater than or equal to 1. Sin inverse of x plus or sin inverse of x plus or minus sin inverse of y. So this is a formula is equal to sin inverse of x into root of 1 minus y square plus or minus y into root of 1 minus x square. That is sin inverse x plus sin inverse y is equal to sin inverse of x into root of 1 minus y square plus y into root of 1 minus x square. If we have sin inverse of x minus sin inverse of y, we have sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. Similarly, cos inverse of x minus cos inverse of y is equal to cos inverse of xy plus y into root of 1 minus x square into root of 1 minus x square. Sorry, this is cos inverse of x minus cos inverse of y is equal to xy plus root of 1 minus x square into root of 1 minus y square. And cos inverse of x plus cos inverse of y is cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. That is, if you have minus here, you will get plus in the right hand side, and if you have plus here, you will get minus in the right hand side. And 2 sin inverse x is equal to sin inverse of 2x into root of 1 minus x square. 2 cos inverse x is equal to cos inverse of 2x square minus 1. And tan inverse x plus tan inverse y plus tan inverse z is tan inverse of x plus y plus z minus xyz by 1 minus xy plus yz plus zx. 3 tan inverse x is tan inverse of 3x minus x cube by 1 minus 3x square. 2 tan inverse x is equal to cos inverse of 1 minus x square by 1 plus x square. Now let us discuss questions appeared in previous year Karnataka CET. So here sin inverse of 3 by 5 minus cos inverse of 12 by 13 is equal to, this is equal to, I have options pi by 4, sin inverse of 16 by 65, 2 by 7 and pi by 2. So I will consider the given expression, that is sin inverse of 3 by 5 minus cos inverse of 12 by 13, which is equal to sin inverse of 3 by 5 minus sin inverse of 5 by 13. So let us see how it is cos inverse of 12 by 13 is equal to sin inverse of 5 by 13. See, if you consider a right angle triangle like this, and if you mark this cos inverse of 12 by 13, so let us take cos inverse of 12 by 13 as theta. So therefore cos inverse of 12 by 13 equals theta, means cos theta is 12 by 13, that is 12 here, and hypotenuse is 13. So 13 square minus 12 square, that is 160 minus 169 minus 144 is 25, which is nothing but 5 here. So sin theta will be 5 by 12. Sin theta will be 5 by 12. Therefore theta equals sin inverse of 5 by 12. So instead of cos inverse of 12 by 13, we can write sin inverse of 5 by 13. 5 by 13 here. I am sorry, here I made it as 13 here. It is 13 actually. I wrote it as 12. Theta is sin theta is opposite by hypotenuse, that is 5 by 13. 5 by 13 means it is sin inverse of 5 by 13 theta. So therefore cos inverse of 12 by 13 is equal to sin inverse of 5 by 13. So therefore sin inverse of 3 by 5 as it is, cos inverse of 12 by 13 is sin inverse of 5 by 13. So just now while discussing synopsis, we have seen the formula sin inverse of x minus sin inverse of y is equal to sin inverse of x minus y. So you can observe sin inverse of x, sin inverse of x minus sin inverse of y is equal to sin inverse of x into root of 1 minus y square and y into root of 1 minus x square. See, that is let me write sin inverse of x minus sin inverse of y is equal to sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. So we'll make use of this formula here. So here x is 3 by 5, y is 5 by 13. So equating, we have sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. So that is 5 square by 13 square is 25 by 169, and y is 5 by 13 into root of y square, that is 1 minus 3 square by 5 square, so which is 9 by 25. We'll simplify. This is nothing but sin inverse of 3 by 5 as it is. 169 minus 25 is 144. Root of 144 by 169 is 12 by 13. Similarly 5 by 13 here, and 25 minus 9 is 16 by 25. Square root of 16 by 25 is 4 by 5. So which is 65 is LCM, and 12 3s are 36 here, 5 4s are 20. 36 minus 20 is 16 by 65. So sin inverse of 16 by 65 is the required answer. So that is option B is the right answer. So we made use of sin inverse x minus sin inverse y is equal to sin inverse of x into root of 1 minus y square minus y into root of 1 minus x square. Tan of 1 by 2 into tan inverse of 12 by 5 is equal to, we have tan of 1 by 2 into tan inverse of 12 by 5. This is what is the given expression. We have to evaluate this. So let us take this tan inverse of 12 by 5 as x here. If you take this as x, then tan x is equal to 12 by 5. If tan x is equal to 12 by 5, it's easy to find cos x. So you can consider the triangle, consider the right angle triangle where tan x is so you can make this as theta. Tan x is 12 by 5. Here it is 12 and this is 5 here. So 12 square plus 5 square, that is 144 plus 29, which is 160. That is, it is 12 square plus 5 square is 169 under square root, that is 13. So which is equal to 13 here. So cos x is equal to 5 by 13, that is adjacent side by hypotenuse. So cos x is 5 by 13. So therefore given expression is equal to tan x by 2. This becomes x by 2 now. Tan x by 2, which is equal to root of 1 minus cos x by root of 1 plus cos x, which is nothing but cos x is 5 by 13, and here also you can substitute for cos x 5 by 13. Upon simplification, 13 minus 5 is 8, 13 plus 5 is 18, so which is nothing but 4 by 9, 4 by 9 under square root, which is equal to 2 by 3. So option C is the right answer for this question.